Ladies and gentlemen, it's my honor and pleasure to be here again with you guys. And welcome to today's technology seminar hosted by Chinese Institute of Engineers, San Francisco Bay Area chapter. I am Yan Shu. I'm the lead volunteer today. And together with me is volunteer Meng. And also our speaker today, Dr. Yixing Xu, or Ethan. So I will be very briefly introducing our organization. Then I will just read very fast Dr. Yixing Xu's bio. Then we will give the microphone to Yixing Xu today. I know that's the real part for the seminar. Okay, this is the event poster. I'm sure all of you have seen this and registered on Eventbrite. Thank you for doing that. Chinese Institute of Engineers, USA, was founded in 1917 in Cornell University by two of the very early foreign students from China, Zhan Tianyou and Lin Hongxun. They also studied engineering in the USA. So over the years, the organization has evolved and expanded in the 100 years. In the USA, there are 6 chapters now. In overseas, there is OCEESA chapter. Also, we hold 3 major conferences annually or biannually. Out of the 3, we have Asian American end of year conference, and we hold this conference every year in the San Francisco Bay Area. So other than San Francisco, we also have chapters in New York, Seattle, Dallas, New Mexico, and Southern California. Okay. So our chapter, the San Francisco Bay Area, was founded 44 years ago in 1979. And as a nonprofit organization, we're serving engineers, scientists, and professionals and students in the community. The mission is to promote technological advancement, networking, and communicating among engineers and scientists, and to promote the well-being of the whole engineering community. Below are some historical moments of our chapter, as in the 2nd annual conference and the 20th annual conference and also 40th annual conference. Okay, in 2020 to 2021, our chapter hosted the Asian American End of Year Conference and ceremony with NVIDIA founder Jensen Huang and AT&T CEO Anne Cho. During pandemics, we have moved virtually everything online to virtual and live stream. And we successfully held the ceremony with over 5,000 views. We also have a career fair online with more than 1,000 applicants. We opened 13 Zoom meetings at the same time, and each meeting room has several breakout rooms for deep discussions with guests, speakers, and awardees. Okay. All right. Year 21 to 22 is also a virtual year for us, but we never stop our steps. We have transformed all the events from physical attendance to virtual attendance. and the advantage about the virtual events that people can join from their home or their location, and at any time. And also we store most of our events recordings on our YouTube channel, including today's seminar. So on average, we hold events on a weekly basis, sometimes every 2 weeks. Okay, so if you are interested, I highly recommend you to check our Eventbrite page. You probably already know that because that's where you registered, and also our YouTube channel, where you can find a series of videos in the past. And last year, we switched back to in-person event, and we held our annual conference purely offline with a few very heavyweight speakers, and also we held a banquet dinner with more than 300 people in the Bay Area. So we invited stars from industry, academia, and also outstanding people from Asian community. So it was a first large-scale in-person event since the pandemic. To note that we were honored to have the California State Controller, Betty, as our keynote speaker, and also IEEE 2024 President, Dr. Tom Coughlin, as our featured speaker in the afternoon session. Okay, here are more photos of the conference, annual conference last year. So we were so excited to see many old friends, new friends in person. And we hope to see you guys for this year's annual conference in the end of April. And thank to our staff members and also volunteers. These are photos to capture our collaboration of their efforts. Okay. And also to thank our sponsors. And these are also our partners that work with us in many events and also getting speaker invitation and so on. Okay, just want to show everyone about the events we held in Q3, Q4 in last year, just to show you that you know we do offer a variety of topics and events, and you might find topics that you are interested in. And we also collaborate with other organizations on some of the non-technical or non-engineering topics like the arts, like art novel, fiction, movies, so on. Okay. And to mention that we do have a weekly coding study group meeting ongoing, and it's been quite busy with a lot of people, a lot of work, and we provide some coding trainings and also interview tips, and also we invite people who recently got job offers to share their job hunting experience with us. So definitely a lot of people they think this very valuable. Okay. And these are more photos of our mission, which is to bring positive impacts to the Taiwanese and Chinese American engineering community. Okay, so today it's Electronic Design Technology Group that is hosting this event, but we do have other groups, the Emerging Technology, the EECS group, and also Biomedical group, and also Young CIE group, all under the Bay Area chapter. Okay, so finally, let me introduce the speaker for today. So Dr. Yixin Xu, also Ethan, he's the research director at Breakthrough Energy, which is a Gates Ventures. as chief scientist and the system architect of energy system modeling project. He leads a team of research scientists, data scientists, and software engineers to explore potential pathways to net zero and build open source software. His goal is to support industry experts, policymakers, investors, and academic researchers in the clean energy transition. Yixin finished his PhD and postdoc at Texas A&M University. He got a bachelor degree at Tsinghua University, all focusing on clean energy. So let's welcome Dr. Yixin Xu.
All right. Thank you very much, Yanshu, and it's a great honor to be invited here to share my work and talk with people who are interested in this topic. All right, so I'm going to start sharing my slides.
Okay, let me stop that. Okay.
And thank you very much for your introduction about your organization. I think you have been organizing a lot of interesting topics. I think in the future, I'm definitely interested in joining some of the webinars.
Yes, anytime. Okay, now the floor is yours, please.
All right, thank you. Okay, can you see my slides?
Yes, we can.
Okay, can you see the full screen or is that
full screen? Yeah,
okay.
It's good to go. Yeah.
Good to go. Okay, all right. So I'm going to start my presentation, and I think considering the diverse background of the audience, I won't go too deep into the technical details, but try to give a better high-level overview about the energy transition and the climate change and how we can tackle climate challenges through research and development and also policy making and investments. All right, I think the first few slides I'm going to talk about the high-level background or context of this climate change thing. So I think if you read about the news websites and watch news, watch TVs, probably you will hear, you already have heard a lot about climate change, about the damages of climate change now and the predicted damages in the future. You probably also heard about in many countries, especially United States, China, and the European countries. These countries are trying to set up very aspiring goals about how to reduce greenhouse gas emissions. So I think I would try to tie up all the information together to show you the whole picture of climate change and how can we tackle climate change. So one of the most important numbers about climate change is the amount of greenhouse gas emissions every year emitted by all the countries in the world. So basically every year there are 51 billion tons of greenhouse gas emissions from all the countries. And among these 51 billion tons of greenhouse gas emissions, China, United States, Europe, and India are the top four. So this is why these regions and countries are trying their best to reduce the greenhouse gas emissions. So why this number matters? Because this is a huge number, and this number climbed all the way from almost zero to 51 billion tons in recent years, just within 1 to 200 years. It's a very near-term thing. And before the Industrial Revolution, there is almost no significant greenhouse gas emissions into the world, and we never need to worry about it. But now it's a very serious issue. And actually, if you live in United States or China or many regions, you are already experiencing the damages from climate change. For example, roughly 2 years ago, there are extreme weather events in Texas. It's extremely cold in February, and it actually froze out the whole Texas and many states in United States, and that causes rolling blackout, and also many people died. I think it's roughly 60 to 70 people died directly from that extreme weather events. and the lack of power, lack of electricity is also serious. I think also in recent months, what happened in California, the heavy rain, the flood, is also the consequences of climate change. And this is exactly why we care about greenhouse gas emissions, because it is effectively warming up the whole world. And now we are trying to control the emission of greenhouse gas and try to control the temperature rise within 2 degrees by the end of the century. So this is a very challenging work. And if we don't do that, we will be fine only in the next maybe 50 to 100 years. But after that, the environment for our children's, for our grandchildren's will be pretty bad. And that's going to hurt human civilizations very seriously, and not just one country, but the whole world. And the goal is to get 51 billion tons of greenhouse gas emissions all the way to absolute zero. And why we need to get to zero? Because this is really like putting water in a bathtub. So if you keep on putting water into that bathtub, one day it's going to spill over. And no matter how small amount of water you put in, as long as you keep on putting water in that bathtub, it's going to happen. So that's why we have to. This is similar to what we're dealing with climate change. So if we keep on putting CO2 into the atmosphere, no matter how small amount it is, it's going to cause significant consequences unless we get all the way down to zero. And this is our goal. And this is a very hefty goal. And we are very far away from it. But a lot of very smart people are doing their best to change the trend, to try to reduce the emissions and get to absolute zero. So how can we achieve that? So getting to zero will be an enormous challenge. So it's basically going to transform almost every activities we know of in modern life. I think some of us already experienced this transition. I think some of us are already driving electric vehicles, already putting rooftop solar panels on top of your house. All these things are gradually transforming our life. And in the next 30 to 40 years, United States and China and Europe and many developing countries, everyone is going to experience significant transitions. So I would say this is a challenge the human has ever faced, I would say, in the past 2,000 years. And this is also the idea from Bill Gates. So this is enormous challenge. We have never dealt with this type of challenge before, but now we have to. Otherwise, our grandchildren will live in a very hostile environment, and that terrible consequences could last for several hundred years. And that's going to be very bad for human civilizations. So in order to get to zero, what can we do? So we first need to understand the problems, to analyze these problems one by one and come up with the solutions. And when it comes to developing solutions, engineering and science are very important, but also other areas in a society needs to also play a very important role in this process. That's why we need to work together. So that basically means besides research and development done by engineers and scientists, we also need the policymakers to make the right policies to support this transition. We also need business people and entrepreneurs to build the market, to build consumers, and to make sure that the business is also solid for this transition. All right, so let's take a look at the total emissions and what contributed to these total emissions. So for the whole world, it's 51 billion metric tons of greenhouse gas emissions. And among this total amount of emissions, we categorize all the emissions into these 5 large categories. It's electricity, transportation, manufacturing, building, and agriculture. So this is how we understand and how we tackle this problem. We divide and conquer. We look at each sector and see where are these emissions come from each sector, and we are going to solve them one by one. And these 5 major categories of emissions are also the 5 grand challenges in our thinking framework. We need to handle and tackle these challenges one by one. The first one is also the biggest one, which is manufacturing. So this is super important because carbon emissions comes from making cement, making steel. As we all know, we are living in the modern industry, we're living in the modern world, and the manufacturing industry is providing us essential materials for us to consume. All the buildings, all the bridges and road, they need cement. We also have steels in almost all the buildings and also all the major infrastructures. So these materials are essential for our modern life, but they also emit a lot of CO2s. So we have to handle them. And right now we don't have very good solutions. The good thing is that a lot of startups are trying to come up innovative solutions, but we really need them to validate their solution, to find ways to scale up the solutions and get down the cost. So now this is a very interesting areas, and a lot of people are trying to come into this area and propose interesting and new solutions. All right. So the next sector is the electricity sector. So we have a generation. We have a generator power plants to generate electricity from all types of sources, and the fossil fuel generations, such as the natural gas and coal power plants. They are emitting a lot of emissions, but we need electricity. And right now we don't have a sufficient amount of clean energy to support our electricity consumption. And this is the area we feel more confident because we already have pretty mature technology, such as wind power and solar power. And the batteries are also becoming cheaper and cheaper. So this is what we're trying to do to increase the deployment of these mature technologies like wind, solar, and battery, and use them to replace fossil fuel technologies like natural gas and coal power plants. And hopefully we can make our electric grid 100% clean. And that is the goal in the next 30 years. Next one is agriculture. So we all need to eat, and we also want to eat both meat and plants. And guess what? Both meat and plants, they emit the CO2s when we are growing them. For example, cows, when we eat beef, we have to raise cows, and those cows emit greenhouse gas emissions quite a lot. Same thing when we are eating rice and other plants. We use fertilizers, and making fertilizers also generate a lot of CO2 emissions. So we need to find innovative ways to ensure that the life quality is good, is the same or even better. At the same time, we're trying to reduce the greenhouse gas emissions. Transportation is another major sector we have to decarbonize. And we already find good solutions for a big portion of transportation, which is pure electric vehicles. Car makers like Tesla, Ford, and Motor, they are doing quite a lot, and they're ramping up quite fast. So if we can replace all the passenger vehicles powered by gasoline today, replace them with electric vehicles, that's going to be a huge CO2 emission reduction plan. And if we can also make our electric grid clean, which means we use renewable energy to generate electricity and use those electricity to charge our electric vehicles, then we can drive our vehicles in a very clean way and in a very sustainable way. However, transportation is more than just passenger vehicles. We also have to find good solutions for heavy-duty vehicles, like those long-haul trucks. Like, they are very heavy, but battery may not be a good solution for them. So now people are thinking about whether we can use hydrogen to power those big trucks. And also aviation and the maritime shipping are also very important. And right now we don't have very good solutions. Now some people are thinking about, hey, whether we can use hydrogen or electric battery to power planes. Well, those are very challenging. So we hope some people can come up with very good solutions for that. And for now, a very hot area is so-called sustainable aviation fuel. So that means we are going to make the aviation fuel in a very sustainable way. It could be using biomass. It could be capture CO2 and then combined with hydrogen and then make very clean aviation fuel. So it is still fuel, but the fuel itself is very sustainable for airplanes. Building is also another very important sector. I think right now in many places in the United States, a big portion of space heating is actually depending on natural gas. For example, I'm living in Seattle, so in Seattle, most of the house heating it depends on natural gas. But burning natural gas can generate a lot of CO2 emissions. So we want to find a good way to replace natural gas in space heating. And now we also have pretty good solutions that is called heat pump. So heat pump is similar to air conditioner. So the difference is that heat pump can actually do both. It can heat your house. It can also cool your house down. So this is a technology already mature. And I think in the next few years, we're going to see a lot of a heat pump being used in buildings to heat up the spaces. All right, so those are the 5 grand challenges. Let's take another look at what is the future trend in the United States. I think the biggest trend in the United States is large-scale electrification. As you can see in these figures, so now we can kind of divide the energy usage into several categories. But in the next 20 to 30 years, we're going to see a lot of electrification from transportation, from building, and other areas. And building and transportation are the largest sectors we are trying to electrify. And if we can successfully do that, that means we're going to double the electricity demand in the next 20 to 30 years. Actually, if the economy continues to grow, we're likely to triple the electricity demand in the next 30 years. And that is a huge amount of more energy we have to find a way to generate. And we have to generate them in a very clean way to completely decarbonize all the sectors in the economy. And this is very challenging. Some studies have been done to look at what's going to be the future for the whole economy, and we see that very likely we're going to see this following scenario. We're going to have a lot more wind power, a lot more solar power, and also nuclear. So currently, a lot of interesting research are being conducted in so-called small modular nuclear. And these are small modular reactor nuclear, and these are new technologies for nuclear power, which is supposed to be very safe, very efficient, and also very clean, because using nuclear to generate the electricity does not generate CO2 emissions, and we can use nuclear to replace fossil fuel generations from natural gas and coal. And of course, in the future, we don't really know what the future will look like, but we can guess what the future look like. We can have different potential pathways to achieve the goal we want to achieve in the future by 2050. So in the United States, the goal for 2050 is so-called net zero emission. That means the CO2 emission generated in 2050 will be offset by CO2, by carbon capture technologies in 2050. Or roughly speaking, we're trying to reduce CO2 emission as much as we can. And if there are still some CO2 emissions we cannot avoid, we will try to capture them and store them. So this is a very challenging goal. Although we don't know what is the pathway, we know that there are several potential pathways can help us achieve that goal. And some of the pathways is going to depend heavily on wind and solar generation, and some of them will heavily depend on nuclear generation, and some of them may depend on new technologies we don't have yet. So looking into the future is very challenging, and we need some modeling tools to help us understand what's happening today and what's going to happen in the future in order to achieve our final goal of net zero by 2050 United States, and also net zero by 2050 in Europe, and net zero by 2060 in China, and of course for many other countries. So in Breakthrough Energy, my work is to build this future energy system modeling system to help understand what we need to exactly in order to achieve that goal. So you can think of this as the digital twin of today's electric system, but at the same time, this digital twin is just the starting point for us to predict or design or plan what's the future. And we can use this tool to help understand what's the optimal or potentially several optimal pathways to achieve our final goal. And we chose to do it in an open source way. I think many of the audience might work in the tech industry, and you probably already know what's the benefits of open source. So by doing it in an open source way, it is transparent and encourage collaborations, and people can reproduce our results. And it's very easy to share, and also it's an educational tool for people who are interested in this area. I'm going to show you a few examples, like how we use our model to study what's going to happen in the future. So one study we have done is to look at a near-term goal, like by 2030, what we need to do in the United States in order to reduce CO2 emissions. And first, we conducted a business as usual study. So this study is using our tool, using our data, and also look at the current growth and current policies. And we find out that if we don't do anything about climate change in the United States, we are not going to reduce a lot of CO2 emission in the next 8 years. And that's mainly because the goals is not ambitious enough, and there are not enough infrastructure built out to support greenhouse gas emission. However, if we have a more ambitious goal for 2030, for example, like 70% clean electricity by 2030, if we set that goal and if we achieve that goal, that means we have to that means we're going to reduce about 50% CO2 emission by 2030 comparing to 2020. So that's a pretty significant CO2 emission reduction. But in order to do that, we have to add a lot more renewable energy into the system, and we have to expand significantly our current transmission system to deliver the renewable energy from source to the demand center. And we did a study to explore exactly what can we do. How can we design the future electric grid in order to achieve the 2030 70% clean electricity goal. And here we come up with kind of 4 different designs, and we call that the macro grid designs. So you can think of as building out interstate highway system in order to support the delivering of clean renewable energy to the demand center. And actually all 4 different designs can help us achieve our goal. And the cost is $1.5 trillion in the next 8 years. So that is a lot of money. And most of the money will be spent on building wind farm and the solar farms. And some of them will be spent on building out the transmission system, which is very critical in delivering clean energy across the country to effectively utilize renewable energy and replace the fossil fuel energy with renewable energy. As we can see in this 4 different chart, the change between 2020 and 2030 is very significant. The green color represent wind power, and the yellow color represents solar power. So if you combine if you compare today's wind and solar generation with 2030's wind and solar generation, you can see a very significant expansion of renewable energy. And that is necessary for us to achieve the goal. So although the cost is very high, the benefits is also very high. So it can help us reduce our dependence on fossil fuel. So that saves a lot of money spent on coal, natural gas, and gasoline. And it also significantly reduce the CO2 emissions and also the pollutants from those power plants, like coal power plants. And that's a huge benefit for the society. And this is an animation of how wind power and solar power are generated during the 24-hour operation. As you can see, when the sun rises in the east, we see the yellow circles representing the solar powers are popping up, and the energy is delivered from eastern to western interconnections. And in the afternoon in California, we also see a lot of solar powers, and the power is delivered from California to eastern interconnections through the blue transmission lines on this map. So the idea is really about building out the nationwide electric grid system so we can effectively delivering renewable energy across the whole country, so that we can keep the cost down for the whole system while utilizing the clean energies to support our needs. And I'm going to quickly go through some technical details to give you a better sense, like how much more renewable energy we need to build. So in this map, this is Texas. So in this map, we show that the yellow circle representing the new solar farms and the green circle representing the new wind farms we need to build by 2030 in order to achieve a certain goal. And on this slide, this goal is to reduce 40% CO2 emission, which means we are going to reduce the CO2 emission to 60% of 2020's CO2 by 2030. And this is already a lot of wind and solar we need to build. But if we have a more ambitious goal to continue reducing CO2 emissions, we also need energy storage. So the purple circle representing energy storage. As you can see, if we have higher goals or more aggressive, ambitious goals of CO2 emission reduction, we really need to build a lot more wind, solar, and energy storage, and also transmission lines. All right, so in many places, United States, building transmission lines is very challenging. So if we have a limit on the transmission lines we can build, we notice that there is a trade-off between energy storage and transmission lines. So the less transmission lines we can build, the more energy storages we have to build to store the clean energy, renewable energy when we have a surplus of them, and then release or discharge the stored energy during certain hours when we don't have renewable energy. For example, solar power is only available during daytime, but during evenings, we also need electricity. Where can we get them? And energy storage could be the solutions. All right, so on this slide, we show today's and the 2030s electric generations. As you can see, we are going to experience significant change in the next 8 years. So right now, we're having electricity from a lot of electricity from natural gas and coal power plants. In 2030, most of the generation will come from clean sources like wind and solar. At the same time, we see a lot of curtailment of wind and solar. And the curtailment here means wasted wind and solar energy. So why we have to waste energy? And that is mainly because for wind and solar, those are intermittent energy resources. So we have wind energy when the wind blows, we have solar energy when sun shines, but sometimes we don't need that much energy, even we have them. And sometimes we need those energy, but the sun doesn't shine and the wind doesn't blow and we don't have them. We have to then rely on natural gas and coal power plants. So there is a very tricky balance between wind and solar and also the demand. So that's why energy storage can play a very important role to store the extra or excessive wind and solar energy when we don't need them, and then release those energy when we need them. All right. So our model can also do other interesting things. One of them is to reproduce what happened in the past and then use that as a base to help us understand what can we do in the future to prevent similar things from happening. So as you all know, in 2021, the Texas power outage is a very serious event. A lot of people lost their lives, and there are significant economic losses because of that event. So we used our open source model to reproduce what actually happened in 2021. And then we proposed different corrective measures to mitigate that blackout if it were happening in the future. One of them is adding energy storage. One of them is adding demand response programs. So here, demand response means that instead of just meeting the demand whenever necessary, sometimes we can actually communicate with consumers and coordinate with consumers' energy usage to effectively reduce the amount of energy needed during certain hours, maybe because we don't have sufficient energy in those hours. And by this type of coordination, we can balance the system out without rolling blackouts. For example, maybe during that Texas outage event, it is beneficial, or it is okay to reduce certain electricity consumptions at homes. For example, maybe during those days, people can choose not to use laundry machines, not use washers, dishwashers, or they can reduce the energy consumptions of their air conditioning, etc. By doing so, what you can actually achieve is that you reduce the total amount of electricity demand, so that even certain power plants is out of service because of extreme weather events. The available generations, available power plants can still support the demand, so that you don't have to go into rolling blackouts, which has very negative consequences. All right. Another great thing about our model is that by doing this type of studies in a very detailed way, we can actually provide quantitative results rather than just the qualitative results. And this is very important for policymaking, for investments, for managing the cost of this new infrastructure or new technology deployment in order to prevent rolling blackouts. All right. And as I mentioned before, in the next 10 to 20 years, we're going to see significant electrification, and some of them is going to happen in building sectors. So today, 70% of the space heating depends on fossil fuel, mainly natural gas. But in the future, we're going to see that most of the space heating will come from a heat pump, which is electrified. All right. So these figures shows that what might happen in the next 10 years specifically. So we're going to see the heat pumps, air source heat pump is going to gradually replace natural gas in both residential and commercial space heating. And if that can happen, then we can significantly reduce the CO2 emissions in building sector. And then we have built open source models to help people understand how to electrify building sectors. Another important one is transportation electrification. So we look at a lot of data, especially the vehicle trips data, to help us understand how people drive their vehicles during a typical weekdays and typical weekends by all types of vehicles. And by doing this type of data analysis, we have a good understanding about the patterns and behaviors of these vehicles. And then we will know that in the future, if we electrify these vehicles, how we can manage the charging of electric vehicles effectively. So this figure shows that if we do not manage the electric vehicle charging, it actually can break the electric power system, because if everyone just directly charge their vehicles when they are, let's say, when they come back from work, and everyone start charging at almost the same time, and we have millions or tens of millions of electric vehicles in a state, that's going to have a huge problems, and the electric power system might be brought down because of this huge amount of charging from electric vehicles. So, however, if we can manage the charging in a very smart way, and that can totally change the consequences from negative consequence to very positive outcome, which is if we can manage the charging of electric vehicles to match the renewable energy generation surplus, then we can truly charge the vehicles with clean energy. And that won't break the system, and that is actually stabilize the electric power systems by effectively using clean energy from wind and solar. And all these things requires a lot of tech industry development to have the communication infrastructure, to have the control strategies, to have a very smart operation of the electric vehicles, and then we can make it happen. And that's going to help us electrify transportation sector. And for demand response, as I mentioned before, and this is about the effectively communicate with consumers so that the consumers can adjust their demand with the generations, so we can fully utilize the renewable energy to make sure that the CO2 emission is low and people's electricity demand needs can still be met. All right, and we are also doing some modeling work for Europe. And our goal is to study not just the United States, but also Europe, China, and other developing countries to provide them very useful strategies and plans to help them decarbonize their energy system. All right. And I'm going to talk a little bit about the concept proposed by Bill Gates, the so-called green premium. So what is the green premium? So green premium is the extra cost you pay in order to use clean solutions to help you meet your demands. For example, you need a vehicle and you have two options. One is a gasoline-powered vehicle, another one is electric vehicles. And currently, the electric vehicle is more expensive than the gasoline-powered vehicles. And that extra amount of money is the so-called green premium. And for electricity sector and transportation sector, the so-called premium is actually not so high. It's roughly 10 to 50%. And this is a great thing because when the green premium is low, that means this new technology is ready for large-scale development. However, for certain sectors like cement, the green premium is quite high. It's about 200%, which means if people want to choose a clean solution over the existing solution, they have to pay twice as much. And that is not good enough. So that's why we need to put in a lot of research effort in finding the cheap enough solutions, cheap enough clean solutions to replace the dirty solutions. And in order to tackle climate change, we really need to work together. It's not just about engineers and scientists. We also need to have policies and also a market and entrepreneurs. And this is how we do it at Breakthrough Energy. So we want to invest in startups to fight climate change. And here are a few companies I listed here. Some of them you may already heard about. And these companies have the technology we think has a chance to be successful. And once they become successful, they could have a huge impact in our life. For example, Form Energy is working on long duration energy storage. And energy storage is a very key technology, but right now energy storage is very expensive and it can only store a small amount of an energy. And Form Energy is developing a so-called long duration energy storage, which is very cheap and it can store a large amount of energy. Right? And other companies are doing very interesting things too, but I won't get into the details. And we also have different programs. This one is the Catalyst program. And this program is about identifying the technologies which is not mature, but has a has a huge potential. And when we put a lot of money in these technologies, so that we want to help them speed up the research and development process and get down the cost really quick, and then make them available as a cheap but also clean solution to the market. And one of them is hydrogen. So hydrogen is definitely going to be a big thing in the future. One thing hydrogen can do is to serve as energy storage. So when we have surplus energy from wind and solar, we can convert electricity into hydrogen and then store them. When we need it, we can use hydrogen and the fuel cell to generate electricity and then convert the energy from hydrogen to electricity in a more effective way. And hydrogen can be used for many other things too. So a lot of fuels can be made from hydrogen combined with captured CO2. And that is very beneficial because we want to capture CO2. And if we can make hydrogen in a clean way using renewable energy, and then the whole process could be very clean and very sustainable. All right, so policy plays a very important role. So we actually published 2 policy books for policymakers to read and understand what they need to do on their side in order to tackle the climate change. For example, last year, the Inflation Reduction Act is the most important policy to fight climate change. There will be close to like $400 billion of funding from US government. And this amount of money will be spent in the next 10 years. So that's a huge amount of fundings generated from this type of policies. And this is very essential to fight climate change. All right, so this is the end of my presentation. And this is all my email and contact information. If you have any questions and comments, feel free to reach out to me through my email. And thank you very much. And I'm looking forward to discussions.
Hi, Ethan. Wonderful, wonderful. Thank you so much.
Thank you.
Yeah, wonderful talk. There's a lot of information, a lot of data-driven approaches, and a lot of promising results. I'm just, let you take a very short break, and also let our audience ask questions. Now we're in a Q&A session.
Sounds good.
Okay, I have a long question here from the audience. I'm going to read it, but you can also open Zoom chat and you can read the question as well from Larry Wang.
Okay.
A few years ago, from a conference at Stanford, the EV was described as not making the carbon generation lower, depending on how the electricity is generated. And lithium-ion battery recycling is not yet included. The green energy is good, but energy storage for green energy is still far from practical. Parentheses, fusion and nuclear not included in green energy in this consideration. So the questions are: 1, can the present approach even achieve the zero carbon goal, or just reducing of the carbon? Second, what's the global optimization effort required to achieve the zero carbon goal? i.e., what is still missing?
These are great questions. I would like to answer, kind of break it down into small pieces and answer them one by one. Definitely, Larry Wang already know quite a lot about the clean energy transition or green energy transition, and raised the very good questions. So maybe start from the first one, like about EV. Yeah, you're absolutely correct. Whether EV is clean or not depends on how the electricity is generated. I can give you a few examples. I live in Seattle. So in Seattle, 70% of the electricity is clean energy because we have a lot of hydro powers in Seattle, in Washington state, which means if someone is driving a a gasoline car in Seattle, and then that person decided to switch to electric vehicles, that's going to be a significant CO2 emission reduction for that person's travel, because that person is switching from 100% gasoline usage to 70% clean energy usage and only 30% of fossil fuel usage. So you can see the difference. It comes down from 100% to all the way to 30%. Another example is that if you are in China, mainland China, and if you drive gasoline car and you switch to electric vehicles, unfortunately, right now, you are not doing much to reduce carbon emission, because in China, 70% of the electricity is generated from coal power plant. And coal power plants is even dirtier than gasoline. And roughly speaking, switching from a gasoline car to electric car in China right now is not effective in reducing carbon emissions. So this is about the CO2 emission reduction right now. However, things are changing, and things are changing very fast. So in Washington State, the goal is that by 2035, we will increase the clean energy percentage from 70% today all the way to 100%, which means if people switching their vehicle to electric vehicle by 2035, in the year of 2035, they are emitting zero carbon in 2035, because all the electricity you get to charge your electric vehicles in Washington State will be clean energy. Similar thing is happening in China. So even China right now has 70% electricity generated from coal power plants. It is rapidly changing. So China is a country building the most wind and solar farms every single year. And all the other countries combined together is still less than the amount of wind and solar built out in China in one country. So we can pretty confidently say that in the next 5 to 10 years, the clean energy percentage in China's electricity is going to increase rapidly, which means they are going to replace fossil fuel generation pretty rapidly. So even today, it doesn't make a lot of difference in China to switch to EV, but just in a few years into the future, 3 to 5 years into the future, it's going to make a huge difference. And normally speaking, a vehicle could be used around like 13 to 15 years. So as you can see, if you switch to electric vehicle today, and you keep on using this electric vehicle or sell it as a second hand to somebody else, but just to keep the vehicle in operation in the next 10 to 15 years in China, that's going to make a huge difference. So although right now it's not the very preferable, but pretty soon in the future, it's going to be very beneficial for the environment. All right, so this is about electric vehicles. Another thing about the lithium battery recycling, that's also a great question. Several years ago, people are making a lot of electric lithium batteries, especially Tesla. However, there's no recycling several years ago. But today, the good thing that many startups are actually start to look at the business of recycling lithium-ion batteries. Actually, one of the companies is called Redwood Materials, and that company was founded by Tesla, by one of the Tesla founders. So I can see in the future, in the next 5 to 10 years, we're going to see a huge battery recycling business, and they are going to help us recycle our electric batteries from the vehicles, but also all types of batteries. So I'm pretty confident that even now, right now, it's pretty nuanced, but it's in the early stage, but pretty soon it's going to change, and we're going to have a major battery recycling business. All right, let me see what's the other questions. So can the present approach even achieve the carbon goal? The short answer is no. The current technologies are not enough to achieve zero carbon goals. I think my estimation is that the current relatively mature technology can help us get to 70% to 80% clean energy, not 100%, not the zero carbon. I think the last 10% and 20% depends on technologies we don't have now. That is why in the next 10 years, it's crucial for us to do two things. One is to scale up the current mature technologies. Another one is to heavily invest in R&D to invent new technology we need to have in the next 20 years to get us to net zero of carbon emissions. So right now, the technologies are not enough, but I feel confident that in the next 10 years, people are going to come up with innovations which are crucial to solve the last 10 to 20% of the CO2 emission. Okay, the second question is, what's the global optimization effort required to achieve the zero carbon goal? This is another great question. Fighting climate change is not one country's mission. It has to be every single country's mission, and no country can be left behind. I'm glad to see China, United States, Europe are doing everything they can to lead this global decarbonization effort. But again, that is still not enough. These three countries and regions need to take the lead, need to do a lot of R&D and bring down the cost, but also later on, they need to provide this technology to developing countries who are not capable of doing this type of heavy R&D themselves to help the whole world to achieve the zero carbon goal. So I think very soon you will see a lot of collaborations between the regions. And sometimes there are geopolitical conflicts between countries like China and the United States. These two countries are competing with each other in almost every single areas. But luckily, in one area, they all claimed that they are going to collaborate. And that area is energy and climate. So they already released a joint declaration of collaboration. So I'm glad to see that even countries which are competing with each other are actually thinking about collaborating in order to achieve the zero carbon goal. So I think globally the collaboration is very important, and each country needs to know what's your strengths, what's your weakness, and the more developed country needs to take the lead and do more to help the world to achieve net zero. Otherwise, we cannot get down to net zero carbon emission all the way from 51 billion metric ton of greenhouse gas emissions. And as long as we have some emissions emitted annually to the atmosphere, we will be in big trouble in the next 50 to 100 years. Right? I think that's my answers to the first set of questions from Larry Wang.
Ethan, fantastic. I'm really amazed your answers, especially highlighting the global collaboration, the global efforts on achieving this even broader goals. And let me read another question from Isu. Can the model explicitly consider the effect of the Biden-Harris administration's Inflation Reduction Act that provides tax incentives and funding programs to build a clean energy economy? Or the model can help the administration decide which technology is preferred option so that a subsidy or tax incentive should focus on those technologies? Thank you.
Yeah, these are great questions. So one way, I think mainly the Inflation Reduction Act is the main way this act is trying to help clean energy industry is by offering tax credits. It's either production tax credit or investment tax credit. So this model can definitely consider this type of impact from the Inflation Reduction Act by adding those lower the cost into our model, because the model basically look at the cost of investment and operation. So by taking into consideration the impact of Inflation Reduction Act, we're basically using lower cost as an approximation of this effect. So when you have a lower cost for clean energy technologies in your model, you're basically going to build out a lot more of the wind and solar and energy storage and hydrogen and other technologies. So yes, this is we can consider the effect, and that is how we consider the effect by reducing the cost of each technologies according to the tax incentives offered from this Inflation Reduction Act. The model can also definitely help the administration to decide which technologies is preferred. Actually, in my presentation, one example I showed is that there are different technologies: wind, solar, transmission, and energy storage, and they all can help reduce CO2 emissions. But this model can help you calculate out what is the cost, right, of each technologies, and what's the optimal mix of technologies. And if we have a certain, let's see, certain tax credits for certain technologies, that's going to put that technologies in a very advantaged positions, which means that technology may be exploited, maybe deployed more in our model, and that can show the benefits of that technology. So we do use the model to help us see what's the potential impact of each technologies, and also help us decide which technology we should bet on. And if we don't know which technology we should bet on, because those technologies are still in development phase, anything can happen, any breakthrough can happen, any surprise or big surprise or bad surprise could happen where we are not sure. What we do is that we use the model to explore different pathways. And for each pathway, we have certain assumptions. Maybe in this maybe in one scenarios, we will assume, hey, let's bet on this new technology and see what's going to happen in the future. And in another scenario, we may say, oh, let's bet on another technology and see what's going to happen in that future. So by looking at a wide range of different scenarios with different assumptions, and some assumptions definitely takes into consideration of the tax credit, tax incentives, and maybe the bet on certain technology or the breakthrough of certain technologies, and that can help us understand a lot better what might happen in the future, and that can help us, can kind of guide us in infrastructure build out. And as we have more and more information in the future, we can update those models to reflect what we have learned, and that can help us narrow down to the optimal pathways to achieve CO2 emission reduction. All right.
Okay, very good. I think that's also why the modeling work is so important. I'm going to read the next question, which is also for now. I personally have one or two questions after that, if no more question from audience. The question here is from Jess. Do you think US have the plan or capability to do the garbage classification and recycling like what China does? I feel like there is currently a huge waste and they can only recycle several types of materials.
Yeah. This is a great question. I have to admit, I'm not the expert in kind of a waste recycling business, but what I know is that there are many startups in the United States are looking at this now. Some of them are using AI to basically classify the different waste or garbage and then recycle them more effectively. I think you're absolutely correct. I think in China, because the labor cost is so low, there is a business around depending on people to do the classifications and recycle a lot of materials in China. But in the United States, that business doesn't make sense because the labor cost is just so high, and there are so much land to be used as a field land to store all the waste there. So the business in the United States is quite different in China. But now I think things are changing. People are thinking about either classification using AI to replace labor. There are business looking at recycling materials like electric vehicles, batteries, and other type of materials now too. I think including like clothes, like fabric. I know that several startups are doing that. So I'm pretty confident in the future you will see a lot more startups working in this area and come up with very innovative solutions. And actually, recently, Breakthrough Energy just invested in a company called Mears. So in that company, what they are doing that they can take in your food waste and other type of organic waste, and they can turn that waste into food for chickens. So basically, chickens can eat those wasted food after some kind of a processing of their technologies. So I think in the future we will see a lot of interesting things around the waste recycling business.
Okay, great. Thank you, Ethan. So since I don't see any new questions from the audience, so I want to ask you a question. The questions may be a bit long. You mentioned that country are so different. They're doing things differently in energy policy and infrastructure. So I personally, I've noticed big countries like USA and China, big countries, they have on the one hand, they have more resources to use, but on the other hand, the size is so large that it's not easy to build a more resilient infrastructure. For example, we have electricity outage in the US, and we have rolling outage strategy happening in the US, in California, in Texas, but also in China. So that's kind of background. So my real question is the following: like which country or which state of the US you think that's doing better, or that's doing ahead of other entities? As a good example, maybe you can comment on that, and what are the good lessons from the good example? Thank you.
All right, that's a great question, Yanshu. So I think the answers are already in your questions. What's interesting now is that we're really in the middle of the transition, and when we're in the middle of the transition, a lot of things are happening at the same time. Sometimes positive things and the negative things are happening at the same time. So you mentioned that in Texas and California, they were rolling blackouts. You're absolutely correct. From this sense, it seems like Texas and California are doing terrible when it comes to fighting climate change or doing the clean energy transition. However, I will also say that these two states are actually the leaders in clean energy transition. The reason is that obviously these two states, United States, their economy are two of the strongest in the United States. And because of the economy is so strong, and also because they need a lot of energy, they are actually leading the country in building wind and solar generations and also energy storage. At the same time, they are also putting out very innovative policies in clean energy transition. For example, like in California, a lot of energy market policies are quite new, and people are really looking up to California's leadership. They are trying to see what California has done and what's the outcome. Is that positive or negative? What type of lessons we can learn? And then other states in the United States are going to follow. So I would say, yes, unfortunately, Texas and California are experiencing rolling blackouts, but at the same time, they are the leaders in terms of innovative policies, innovative technologies, and the willingness to try new things. So I would say they are doing quite well. It's unfortunate that rolling blackouts are happening in the two states. I think there are a lot of reasons behind this. One of the reasons is that the United States, it's very hard to do big infrastructure project, United States. For example, we really encourage United States to build out a lot more transmission lines, because transmission lines can help you deliver cheap, clean energy from your neighbor states or from basically anywhere to the demand center when you need the energy. However, it is not happening in the United States, mainly because policy-wise, it's very difficult. So United States, if you want to build a long-distance transmission lines, you really need to have everyone's approval along that transmission line. That could mean hundreds of people, hundreds of stakeholders' approval in order to build one transmission line. And that is very difficult. So basically, United States, what is suffering here is that the lack of necessary infrastructures. And for California and Texas, it become serious than other states simply because these two states have the best economy in the United States, which means they also need to consume a lot of energy to have a great economy. So they consume, the demand in these two states are very high. However, the infrastructure is lacking and causing that the generation is not matching the increasing demand. So that's why it's kind of unfortunate that these two states are experiencing rolling blackouts. But at the same time, I think they are doing great in terms of great policies and deploying new technologies. So my prediction is that this year, energy storage is going to be a huge business in these two states, especially with the Inflation Reduction Act. And other states will definitely follow Texas and California in the following years in deploying wind, solar, and energy storage in large scale.
Great answers, great answers. Thank you. It's good to know that you have a dialectic view to to see to see good and bad at the same time and have a more fair and more objective evaluation of these things. And Larry Wang has another question or comment. Maybe you want to look at the question while I'm reading because there's some numbers. So he said, recently I ran across a paper about the precipitation of the last 9,000 years, right after the glacier period. The short version is that the precipitation regularly reduced over the millennium till 500 years ago for turnaround. But with the drought in the west part of US and many parts around the world, that will hit the zero carbon goal. Is desalination plant like in Israel another area of effort? But to be honest with you, I don't quite understand the question. It's quite technical. Yeah.
I'll try my best.
Go ahead when you are ready. Yeah.
So I'll try my best to answer it. If I missed something, maybe Larry can also jump on the video or audio, and we can discuss. Yeah, I think the drought recently in western part of the United States is a huge issue. I think water will become a huge issue because of climate change, and this is already under our radar. So desalination is definitely feasible in our view. So the cost of desalination is already going down quite a lot. In some places, we think this is a very valid solution. The cost is not significant. It's more cost. Yeah, it's more costly, but it's not that significant. So for regions which has access to water, even seawater, this is the solution, valid solution. We have looked into it, and now the problem is, okay, let's build the desalination plants along the coast to convert the seawater into drinkable water or other types of water for aggregation, etc. It is definitely feasible. We're also looking at other interesting topics, such as what if a region in the middle of the land and far away from the sea, that place cannot have access to even seawater. What can you do next? And we are thinking, we're looking at technologies which can extract water from the atmosphere. That is more costly, but it is a solution. We are able to extract the water from the air and condense them into usable water. So this is going to be a huge problem in the future for sure. the lack of water. But now we have identified certain technologies which has the potential to be scaled up and solve this problem. All right, I think there's another question. Yanshu, would you like to read it?
Yes, sure. Another question from Jess. Thanks for your insightful answer. And how do you think of light usage in US? I'm always wondering why people don't turn off building lights at night for either university buildings or commercial buildings. It's a waste of sponsors' money. Is there a rationale behind this common phenomenon? Is anyone trying to solve this? Carbon credit might be helpful, but not sure about its feasibility.
Yeah, I have to agree with you, Jess. So I'm from the mainland China, and we don't keep lights on when people are not inside of a building. And for me, it's also a cultural shock to see a lot of buildings in the United States, no matter whether it's university buildings or commercial buildings or even residential buildings, the lights are kept on all night long, or even when people are not there. I think that is a terrible habit. Mainly because the cost is just too low. People don't even want to bother to turn it off to save a few cents. That is terrible, but I think it can be definitely solved, especially with current technologies, the Internet of Things, the very cheap sensors, especially those motion sensors. I think it can be solved, and I'm pretty sure it will be solved very quickly. Not for economic reasons, but mainly because more and more people like you care about it, putting pressures on like building operators or building owners. So I think that's going to happen. And I already know that in many buildings, especially modern buildings, they have technology which can detect emotions and then have a very reasonable schedule to turn off the lights. And also certain buildings have a solar rooftop panels which can generate electricity to keep the lights on. All those things are happening right now, and I think in the future it's going to. I think United States is going to change their habit of wasting energy on lighting.
Great observation. Thank you. And I only see one more comment from audience. So I want to ask you another question, maybe a final question before we wrap up, about your personal insights, or after hearing your presentations, I can't help thinking about normal people like me just chase trivial things every day, but a person like you're trying to solve a very difficult, very challenging questions that is tied to the humanity, destiny, and for the whole world, caring about the big goals, shared common goals, and really care about sustainable development, right? This word we heard for many years, for many people, but and what is your personal path and passion? What drives you to take on this challenge?
First, thank you very much for your very kind words, Yanshu.
Okay.
So, and I believe you're also working. We are also working in the same industries. You're building softwares to help fight climate change. I think that's also very impactful work. And yeah, I think the impact of software is something we already see in the past several decades. So I think your work is very impactful in fighting climate change. So we are in the same camp. So thank you very much. And I think everyone is doing everything they can in their own way to fight climate change. So my own personal experience has been that I think roughly about 10 years ago. So I started doing research in renewable energy integration, and at that time, we already know there is an issue about climate change, but at that time, no one really cared about it. Besides some people who are already studying in this area, noticed that this is a huge problem. I remember in 2014 when I first started this project. the renewable energy generation in the United States is less than 4%. Less than 4% of wind and solar energy in 2014. That's a very small amount of energy. And luckily, I think we have some big figures in the world, like Bill Gates and several other people. They are really visionaries. I think Bill Gates looked at this problem and he started to think, okay, if no one is doing things to help fight climate change, he's going to take on that task. So I was really inspired by his actions, and I was lucky enough to get his support in working on this type of modeling project to help people understand what's happening now and what's going to happen in the future in order to fight climate change. And think in 2014, really, there were almost no extreme weather events caused by climate change, and people are really not thinking about it. But today, a lot of places, including Texas and California and around the world, like China, Pakistan, and a lot of places are experiencing the damages from climate change, and people start to notice that, hey, we have to do something about it. So I'm glad to see that today the renewable energy percentage is about 15%. So that's a significant increase from 2014's 4%. So I'm encouraged that many people are working in this area now and start to take things very seriously. And I think everyone here listening to me, sharing my experience, my kind of ideas about fighting climate change, I think these people are all care about it. And maybe you're not necessarily working in this industry. So this type of things are very encouraging. I think more and more people will definitely start to think about the climate change and start to do something in their own life to help us fight climate change. And I do think not just engineers and the scientists working in this area can do something to fight climate change. I think everyone can do that. For example, I think in many places when you are using electricity, you can actually choose to maybe pay a little bit more to use clean energy, to use clean electricity to be supplied to your home. In Seattle, I'm choosing the so-called green power. So that is about maybe $8 more expensive every month for the Puget Sound Energy, which is a local utility, to supply me with 100% clean energy, called clean electricity. So that's a little bit, only a little bit more expensive, but that is a difference I can help to make in my life, right? Same thing, if people are willing to switch to a little bit more expensive electric vehicles, that's going to be a significant CO2 emission reduction during the lifetime of the electric vehicles. And I'm sure there are many small things, for example, related to recycling garbage, or many small things people can do to help fight climate change. And I encourage everyone to do that. All right, back to you, Yanshu.
Thank you. Thank you. I don't see more questions from the audience. I have to say we're closing this conversation. It's really great to have you. So Ethan, thank you for sharing your knowledge. Thank you for educating everyone here. And most importantly, thank you for sharing your wisdom.
Thank you very much.
You really take a very unique and intelligent approach in your work, and also answer audience questions. We know that you're based in Seattle, and most of our audience are from San Francisco Bay Area, and we really appreciate you come to here and give us this wonderful talk. And also you happen to answer my bonus question, which was what can you say to younger generation or ordinary people? What can an ordinary person do to help? I think you really encourage us, take on more renewable energy by spending a little extra
I mean, given everybody's affordability, right? I think that's all great, and so we're concluding here. Dr. Yixin Xu, yeah, thank you so much, and we learned a lot from you and from this. A lot of the efforts are actually behind the scene.